So before we jump in and start wire wrapping, I want to talk a little bit about the process and the tools we're going to use. So this is obviously the back of the card that we looked at in the previous video, and I've added onto the back of this card these wrap ID tags. I've had these for potentially decades. I don't know how old they actually are. On each one I've written in the chip designator, so the A through N, or Q actually, A through Q, and you can see that they show the pin numbers, you know, from the back of the device, a pin 1, 2, 3, etc. And this just makes wire wrapping a whole lot easier. So if I know I need to wrap to, you know, device A pin 12, it's right there. It's nice and visually easy to find. I'm not, you know, trying to count pins. And with the bus number down here, you know, 2 to 9, 10 to 17, etc., it'll make wrapping this a whole lot easier. I only had 7 of the 24 pin, and I sacrificed a 28 pin to kind of get some numbers on here to make it a bit easier and consistent. Don't know if you can buy these anymore. They're fairly specialist, I don't know. Kind of a closer look in at these again. You can just see the sea of pins here we're up against to get this all wrapped. And if this actually renders, there it is. Nice side view again showing the sea of pins. Something to mention here is you may notice there's different lengths. These are really long. These are much shorter. That really has to do with how many wraps you can get on it. So these tend to be able to take 2 wraps. These could probably take 3 or 4. It just has to do with how many wires you think you're going to get wrapped onto each one. There's just kind of a look at the bin of the tags, you know, the wrap IDs that I've got. So the tools, I use a pair of wire cutters, a little screwdriver to kind of move wires around and hold them in place, and the wire wrap tool itself. And we'll look at the tool here in a bit more detail. There's the wire wrap tool. I know this is really hard to see in the video. There's the large hole in the end down here that the post goes into, and there's a very small hole in the channel that runs the length here. You can kind of see it. And the wrap wire goes in the small hole and comes up through this channel. And then you put the tool over the large post, and when you spin the tool, it wraps the wire around the post. This is known as a modified tool, I believe, in that the insulation on the wrap wire can actually push up to this point here where this gap is, and the gap allows you to see the insulation. And that way you basically get, you know, I think it's a turn and a half of insulation wrapped around the actual post before then the wire gets wrapped on. Kind of another view with the tip of the tool. You can see maybe the channel here a little bit easier that the wire to be wrapped feeds up into. The stripping tool is stored inside of the wrap tool. You can kind of see here, you know, the little cutter for the insulation stripper. You push the wire down in and pull to remove the insulation. Of course, the tool with the end cap back in and the stripping tool. The wire wrap wire we're using, it's just standard 22 gauge. Don't quote me, I may have that wrong. So you can kind of see, I mean, this tool's about 1 inch long, so this is fairly small stuff we're dealing with here. Here I've got the tool pushed onto the wire to be stripped, and I've stripped the insulation about half off the pull here. So you can see, you know, the wire just pushes down to that groove, cuts the insulation, and you slide it off. And of course, apologies for the wire being out of focus, but the insulation removed and the bare wire here exposed. So that really runs us to the end of the photos here to talk about the tool itself. So let's go ahead and jump into some video and take a look at actually doing some wrap joints. So now that we've taken a look at the tools, let's jump in and actually do some wire wrapping. So I've blown up a section of the schematic here. This is what I'm going to wrap today, at least in this video. And of course, we've got the board, and we looked at the fact that we've got the wrap IDs on the back to make this easier for me. We took a quick peek at the tools a second ago that we're going to need. And the first thing I'm going to do is wrap, make sure I get this in video, these 3 pins to +5 on device A. So device A is sitting right here. There's a little A written on the wrap ID down there. Because it's +5 power rail, I'm going to use red wrap wire. And I need to take pin 6 to pin 11. So I will strip a little bit shy of 1 inch of the insulation off to expose the bare wire. Actually, I need to swap glasses here or I will never be able to see what I'm doing. I'm trying not to bump the camera. Oops. Trying to get the wire loaded in the tool and into the right place. Wow, I'm out of practice. There we go. So I want to get to pin 6. And that's going to go to pin 11, which is over here. Cut this to about the length I need. Strip it. Get the wire in the tool. Get over pin 11. And we'll wrap that. Then I'm going to need another piece to go between 11 and 12. And we'll cut this in advance, because there won't be a whole lot of insulation length left. You can get the wrap wire, you know, in various lengths pre-stripped. I'm not going to do that. I'll just go ahead and when I get to pin 12, then I'm going to daisy chain off of pin 11. Boy, I can tell I am out of practice doing this. It's been a long time. Over to pin 11, and hopefully that'll wrap and not catch. And it did. Then I need a piece to tie off to +5 power rail. Am I somewhat working on camera here? I can tell that visibility is going to be an issue for me. As I've aged, my eyesight, of course, has gotten worse, and it makes this kind of work a little more difficult. And this is just going to come over here to this 5-volt rail. So I will cut much more than I need. Strip it to a good working length. That'll tack down there just fine. We'll add a bit of solder on that 5-volt bus. Tack him into. Get him down into place. Maybe. Well, that's not the screwdriver I need. I need the flat blade to kind of hold the wire in place. Maybe. Wow, this shouldn't be this fiddly. I can't keep it stick. I'll just tack that onto that 5-volt rail. If I had a pair of I've had an X-Acto blade here that may have been easier to trim, but that should take now pin 6, 11, and 12 to +5. So we have accomplished this. Now I need to make a decision here what color I'm going to use for address bus lines, and I think I'll go with white. If I can get the wire to come off the roll here. And we're going to go to pin 5. Trying to keep stuff in camera shot. It's got some tarnish on the end from that wire being exposed to the air over time. We want to get over to pin 5. And that's going to go to 32. Find 32, 33, 32 is right there. So let's find kind of a clean way to bring this over to 32. Being that this is a low-speed machine, low-speed bus, you know, relatively speaking, I'm not too worried about, wow, that was hard to strip, about keeping these super clean and short. I'm going to route that over here to 32, which is right here. I really don't want it pulling up tight, so I'm going to hold it back out of the way. And we've picked up A15. It's not a great looking wrap joint because it didn't finish wrapping. I wonder why. Well, we're going to redo this wire. Something didn't work well there. And try again. Actually, the wire broke, it looks like. So, again, pin 5. Helps if I pick up the right tool. Ran around over here to there's a spot here in the insulation where the wire has been damaged. So we're going to unwrap this one as well and try a third wire. Third time's a charm. The wire looks clean now. I wonder why that insulation got all mushed up there. That's weird. Third time's a charm. Pin 5. Kind of looping around here to 32. I didn't make that too short. I don't know why that's being so hard to strip. Of course, this wire, who knows when it was manufactured, it's pretty old. Loop around here to bin 32. Again, I don't want that pulling up tight against that other. There we go, that looks better. So 5 to 32. 4. Is there a date code on this? I don't see one. Apologies if I'm off camera for some of this. Pin 4 goes to 86. Which is about there. So one of the reasons I picked this board is in the copper, it's actually got the numbers on those wrap pins down there for what bus pin they're connected to, which is really handy. That's gonna, so there's 83, 84, 85, 86 should be right there. A14 to 86. Pin 3 to 85. Having the wrap IDs makes things much easier because the pin numbers are of course labeled. So that's going to end up Next two. Pin 86 that we wrapped a second ago. So that's going to come across here. I may have that a little too long. Strip back a little bit more. Shorten it a bit. I said that goes to 85, and that would be 83, 84, 85. Again, I don't want it to pull it super tight against the other socket while I wrap. We're going to go to pin 2, which goes to 33. Pin 2. Comes over here to 33, which is on the end there. Yeah, getting a little better at this with a little bit of repetition here, kind of bringing the skills back, and that was to 33, correct? Yep, that's to 33. That's a little bit longer than I'd like. So let's strip a little bit more. Trim it a tad. Just trying to keep it kind of neat. That's to 33. And A11 to 87. So it's pin 1 on the device. And it goes to 87, 84, 85, 86, 87. So over there. Might be a little long. There's the large hole in the center of the tool that the pin goes into, and there's the small channel up the side that the wrap wire goes into. And at the moment I can't get it into the channel again. There it goes. And that went to 84, 85, 86, 87, so it goes to right here. Hold that down so it doesn't pull tight. And we're going to do a sanity check. We should have pin 5 to 32. We should have pin 4 to 83, 84, 85, 86. We should have pin 3 to 85. We should have pin 2 to 33 on the bus. 33. And we should have pin 1 going to 87, 83, 84, 85, 86, 87. So those all check out okay. So we've taken care of these leads. Let's move further down and pick up these three here. So we're on to device B. And the problem is the way I laid this out, I ended up with device B over here. When I realized what I'd done, I didn't want to label all the devices. So it goes A, B, C, D, E. It just is what it is. Such is life. Not a big deal. So pin 13. And luckily the little wrap ID, that's the number right there, makes it nice and easy. I don't have to try to count it out. Pin 13. And that goes to 37, 33, 34, 35, 36, 37. Forty-one, 40, 39, 38, 37, 33, 34, 35, 36, 37. So that is 37. And then we have pin 14. This guy right here. $14 goes to 34, which is right there. And 34 should be right here. And then we have pin 15 on the device. And 15 is going to go to pin 84. Right there, 84. And 84 is right here. And we're going to do a sanity check again. So we should be from pin 13 to pin 37, 33, 34, 35, 36, 37. We should be from pin 14 to 34 on the bus. And we should be from pin 15 to 84. Excellent. So we've got all 8 of those address pins brought through. You can mark these guys off. Now we need to bring this control signal from pin 8 to pin D. I'm going to use yellow for the minus 9 volt, I think. Maybe I'll use brown. Yeah, I'll use yellow for control signals. So I need to get to pin 8 here. And that's going to come across to pin 12. 12. I want to kind of hold that wire in place while I start to wrap. Otherwise, it'll pull the wire up really tight if I don't kind of hold it back. And that should take me from device A, pin 8, to device B, pin 12. And we're golden. So that really took care of this. So you can see for a small amount of logic like this, that's not too bad to do. You could do the same thing, of course, point-to-point soldering. Wire wrapping, I think, is just easier. When I get up here to where these are all bussed together on the ROMs, it's going to be a lot of work, you know, pin 1 to 1 to 1 to 1. Across all A, you know, with pin 14 being the only, you know, select pin. But for now, this is enough to test. We can put the two TTL devices in. We can plug this card down into the machine with the two devices in. Grab the logic probe, and from the front panel we can test whether this seems to be working or not. So hold this up here, you can get a little view of what I've done. I'm using white for address bus, yellow for control signals, red of course for +5. Looks good. We can do one other sanity check while we're here. I'll go ahead and do that. So I'm going to clip onto the +5 volt rail and do some continuity tests here. If I can get that to actually clip on there. So on device A, 14, 13, we should have continuity 12, 11, and 6. And that's these three wires here. So from the front of the board, we also see I got those tied to the 5 volt rail. And of course we'll see the power pins on every device are picking up 5 volt, and I actually did a bit of rework on the board and I haven't verified this. I want to get to ground and check the grounds as well. I had to replace the sockets down here and hadn't actually come through and just verify the power rails were hooked up correctly. I hate to admit it, I accidentally put in 14 pin sockets down here initially and then had to rip them out and put in 16, and we got an issue right there. That should be a ground and it's not. Oh, there it is. I'm just not getting down into the socket. Okay. So we're good. We've got power we expect power to be. We've got ground where we expect ground to be. We've used the continuity mode on the meter just to buzz things out. Make sure it makes sense, and that really should give us the address decoding for the upper 2K block of RAM, and then the 8 selects down here to pick which 256K block we're going to use, and each 256K block is of course occupied by a single 1702 EPROM. So I will wrap this little bit of a wire wrapping demo up here, and I'll see you in the next video when we test this.